Hi class, this is 11.1, areas of triangles and parallelograms. So postulate 24 says, here is the area of a square postulate. The area of a square is the square of the length of its sides. So if you think of a square, 4 right angles, all 4 sides congruent. So this would be a side, and that would be the side, and they're the same length. So area equals a side squared. Postulate 25, the area congruence postulate. If 2 polygons are congruent, then they have the same area. Postulate 26 is the area addition postulate, and it says the area of a region is the sum, so if we add it together, of the areas of the non-overlapping parts. And we use this when we have a shape, maybe that's like a really strange shape like this, where we could find the area here, and we could find the area here, and we could find the area here, and then add those all together. All right, theorem 11.1 is the area of a rectangle. So it says the area of a rectangle is the product of its base and height. So product means multiply. So if I draw a picture here of a rectangle, I'm always going to put the B for base on the bottom and the height on the side, and my area equals my base times my height for a rectangle. And then our next shape here for this lesson is parallelograms. So here's a picture of a parallelogram. Opposite sides are congruent. We've already studied parallelograms a little bit here this trimester. It says either pair of parallel sides can be used as the base. So you can use either pair as the base, but the height is the perpendicular distance between the bases. So whatever 2 bases you pick, the height has to be perpendicular between those 2. This last piece here says if a rectangle is transformed into a parallelogram. So picture this rectangle and just kind of sliding the top over here to change it into a parallelogram. With the same base and height, the area is the same. So the area for a parallelogram is still going to be base times height. Still, even for a parallelogram. Let's look at the next page here. Okay, that first page just had a lot of different kind of definitions for us. We're going to do one more here and then use our ideas. It says the area of a parallelogram is the product of a base and a corresponding height. So example 1 says find the area of a parallelogram. So we know for a parallelogram my area is going to equal my base times my height. And there's really 2 options here for this one. So what we could do is, first of all, we could think of this as our base, and then the height would actually be this 4 over here, because even though this height isn't touching this base, it's still parallel to this base. If I slid it over, it'd still be parallel. So one way we can do this, we can say the area equals the base of 9 times the height of 4. So my area would equal 36. And my units here we don't have, so we're just going to put units squared. Then our second option for this problem, just put option 2 here. I'll do this one all in red. We're still going to say area equals base times height. This time, though, I'm going to say my area right here, that's going to be my base. So my base is going to be 8, and I need a height that's perpendicular to it. Now I know this is a parallelogram, so these 2 red sides are parallel, and then this would be the height that is perpendicular to my bases. So 4.5 would be my height if I'm using the red base. So my area equals, if you do 8 times 4.5, you're still going to get 36, and we're still going to say units squared. So notice, depending on what my base is, my height changes. And either way, though, I still get the same answer. So try this next one on your own. Okay, you should be saying, okay, the area of a parallelogram, that's a key piece right there that I'm finding. So for a parallelogram, area equals base times height. So this 17 up here is my base. My height has to be perpendicular to it, which would be right here, 7. So my area equals my base of 17 times my height of 7. So my area equals 119 units squared. And notice for this one, I couldn't use 10 as my base because I don't know the perpendicular height. I don't know the perpendicular height between these two bases. Okay, the next part here is talking about triangles. It says Theorem 11.3, area of a triangle. The area of a triangle is 1/2 the product of a base and its corresponding height. So for a triangle, area equals 1/2 the base times the height, and again, your height has to be at a right angle from your base. So this example 2 here, I'm going to draw a couple pictures in. So I'm going to do this triangle, I'm going to put a right angle here, and say this is 13, down here we have 10, and right here we have 20. And then I might as well draw this next triangle in as well. This triangle I'm going to make it look a little bit different. Look just like this. And then outside of it, I'm going to put this dotted line, and that means that's not part of the triangle. But I'm going to put this 9 here, and that's going to represent the height because it's going to be parallel to this base over here of 15. And then I'm going to draw one other one on here. Well, actually, I'm not going to do this on your own A. We'll just do the B part. All right, so let's look at the problem that I just drew for example 2A. We know for a triangle, area equals 1/2 the base times the height. Now, my base for this, so area equals 1/2, my base is going to be this entire piece right here. So we're going to have to say 20 plus 10, which is 30, times my height then is this because it's at the right angle, so my height is 13. So area equals 1/2 of 30 times 15, I'm sorry, 1/2 of 30 times 13 is going to be 195. And again, we don't have units, so we're just going to put units squared. For part B here, it's a triangle still, so we're going to say area equals 1/2 base times the height. So my area equals 1/2. My base is down here, this 15, times, and my height has to be perpendicular to it. So my height is actually over here, because if I slid that base over, that would be the distance between the base and then the top of the triangle. So my height is 9. So if you multiply that out, area equals 1/2 times 15 times 9, you would get 67.5, and then that's units squared. Let's do the on your own B. So we're going to say again, it's a triangle, so area equals 1/2 of the base times the height. My base is going to be this whole piece down here, and then my height is going to be this 28, because those are perpendicular to each other. So area equals 1/2 my base, which is really 45 plus 21, times my height, which is 28. So if you put that all in your calculator and simplify it, you should get 924. And again, we're going to say just units squared here, since we don't have a different unit on our picture. And let's flip it over to the last page of this lesson. Okay, it says finding unknown measures. It says the base of a triangle is 4 times its height. Okay, so let's put what we know there. Base equals 4 times the height. And we know we've got a triangle. That's also a key piece. It says the area, okay, that's my A, of a triangle is 50 square inches. So equals 50. And that's inches squared. Here's my direction, so I'm going to put a box around it. Find the base and the height. Now, I know my base is 4 times the height, and look at I got a nice picture over here. If we didn't have it, you could still draw that in there. So this is my height, and then this right here is my base. So my formula, area equals 1/2 the base times the height. Well, my area in my direction says it's 50, so it's 1/2 times the base we know is 4h, and the height is h. So to solve this problem, I've got really 50 equals 1/2 4 times h squared. So I've got 50 equals half times 4 is 2h squared. Divide both sides by 2. Move it up here. 25 equals h squared. Take the square root of both, so my height equals, really it's positive or negative 5, but we're not going to have a negative height. So my height is 5, and my units would be inches. So there's my height. And then my base, well, that's going to be 4 times 5. So my base is going to equal 20 inches. The question said find the base and the height, and I did that. So try the next one on your own. Okay, looking at it, it says a parallelogram. This one doesn't have a picture, so I'm going to draw a picture in here. Just draw a parallelogram in here. It has an area of 133 square feet. So I know A equals 133 feet squared. And a height of 19 feet. Okay, on my picture here, I'm going to make a right angle from the base, and this is that's 19 feet. Here's my question. What is the length of the base? So we're looking for B here. So for a parallelogram, let's write our formula. Area equals the base times the height. Well, we were told the area is 133. The base we don't know, so we're going to put B times the height is 19. So solving this, I'll divide both sides by 19. So my base equals 7. And then my units there would be feet. And the question says, what is the length of the base? And I found that, so I'm done. Let's look at these last two problems here. It says example 4, a robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes. So 2 square meters of carpet in 8 minutes. I'm just going to write a fraction there. 2 meters squared in 8 minutes, because that's a ratio. Here's my question, how long does it take? So how long does it take? So we're looking for a time. I'm guessing it's going to be in minutes for it to clean the carpet covering a room with dimensions shown below. So we need to find the area, first of all. Okay, so the area here of this piece would be 5 times 5, base times height, so that's 25 meters squared. The area over here, well, if this whole piece is 9 and this piece is 5, then we know up here we have a piece that's 4. So 9 times 4, my area up here is 9 times 4. So that's 36, and again, that'd be meters squared. So my entire area is 36 plus 25. So my entire area is 61, and that would be meters squared. Now, I know, though, that I want my answer is how long. So I need to take my meters squared, and I want to multiply this and end up with minutes. Well, if I multiply it just like I've set up here, the top and bottom will cancel, and minutes and meters squared don't cancel. So I need to flip this around. The problem I actually need to do is 61 meters squared times, I'm going to put my 8 minutes on the top, over 2 meters squared. What that'll allow me to do is it'll allow my meters squared to cancel out. So really we're going to do 6 times 8 divided by 2, and then my units will be minutes. So if I do 6 times 8 divided by 2, that'll leave me 244. That's not 244. Let me check it out here. It's not 6, it's 61. Silly me. 61 times 8 divided by 2. That's 244. And my units would be minutes. So it'd take me 244 minutes for that robotic vacuum cleaner to clean it. This on your own says, suppose there are 4 sections of carpet measuring 1 meter by 2 meters. So it's 1 meter by 2 meter. So that area, 1 times 2, would be 2 meters squared. That are covered and cannot be swept. That's a key thing, so we got to take that out. Here's my question. How many hours does it take for the robotic vacuum to clean the carpet? Okay, now how many hours? It's a key thing. We had minutes in the previous one. So we're going to start with this 244, but we got to take away the time or the carpeting that it can't clean. So I've got 4 sections that are both 2 meters squared. So 4 times 2, I got 8 meters squared that can't be cleaned. And let's figure out how much time that takes out. So that takes out 8 minutes for every 2 meters squared. Let's cancel out our meters squared. 8 times 8 is 64. Divide by 2, and that's in minutes. So we got 32 minutes that we can't clean. So I'll subtract 32 here. So I've got, let's see here, 212 minutes. And then I want hours though. So I have to take and divide my 212 minutes by, let's see, I have 60 minutes per 1 hour. I want minutes to cancel though, so I got to cross that and do the opposite, 1 hour and 60 minutes. This looks like I'm going to do 212 divided by 60. And that leaves me with about 3.5 hours. This is the end of the lesson. Make sure if you have questions, you ask me about it in class. Have a great day.